Today we're going to cover lessons 103 and 104. So you'll be doing odds on 103 and evens on 104. All right, so on page 583, we're going to be simplifying this first problem into one logarithm. Okay, and then in the second problem, we'll do just the opposite. So we're going to have to remember our laws of logarithms while we're doing this. Oh gosh, I wrote really big. Sorry about that. All right, so the first thing we can do is apply each one of these exponents. So this 3 is an exponent here, 2 is an exponent here, 4 is an exponent here, and 2/3 is an exponent here. So then it will simplify to ln of x squared minus 1 to the third minus ln of y squared minus ln of x plus 1 to the fourth, and then plus ln of, I'm going to write this as y times y plus 1 to the 2/3, because that y squared plus y is eventually going to have to be factored anyway. All right, so now remember, when logarithms are added, it means that the arguments are multiplied, and when they're subtracted, it means that the arguments are being divided. So the ones with pluses will come out here with the ln. The ones that are positives are in the numerator. They're being multiplied. So then that's times y to the 2/3 and y plus 1 to the 2/3. And then in the denominator we have y squared times x plus 1 to the fourth. All right, so then the last thing we can do is we don't want to leave a y by itself here and here. So we're going to go wherever that's going to remain positive. And let's see. That would be ln. Do we have? Oh, yes. And this also, this will factor into x plus 1 to the third times x minus 1 to the third, because that's a difference of 2 squares. And then I'll leave this y plus 1 here to the 2/3. Down here, I have the x plus 1 to the fourth. And if I take the 2/3 and subtract it from 2, that would be y to the 6/3 minus 2/3 would be 4/3. And then lastly, to simplify it, we can take this x plus 1 to the third and cancel it in here and leave us with just x plus 1 to the 1. So the final answer will be ln of x plus 1 to the third times y plus 1 to the 2/3 over x plus 1 and then times y to the 4/3. So we took this long expression and we simplified it down into one logarithmic expression. All right, now then, the next one is just the opposite of that. It says expand the following into the sum of logarithmic expressions, each of whose argument is linear. So nothing other than a linear expression. So it starts out as log of x y cubed over the square root of x plus 1, and that's here, and the z cubed is also underneath there. All right, so let's start breaking this thing down. Let's get rid of this mess in the denominator first. So that would be log of xy cubed, and this will be the same as x plus 1 to the 1/2, and then z to the 3/2. And now we got rid of the square root. Okay, now remember, if they're multiplied, the logarithms will be added, and then all of these that are down here will be subtracted. So this will be log of xy cubed minus log of x plus 1 to the 1/2, and then minus the log of z to the 3/2. And then remember, these are multiplied, so this is going to be log of x plus log of y cubed and then finally we'll remember that the exponents come out in front as powers. So this will be log of x plus 3 log of y minus 1/2 times the log of x plus 1 minus 3/2 times the log of z. All right, so we shrunk one down and we expanded the other. All right, let's see. Bottom of page 584. We did this in Algebra 2, but it's been a long time ago. So the formulas are given in the middle of the page, and if you're in chemistry, you already know this. 10 to the minus pH is equal to H plus, or the hydrogen ion concentration, and pH is equal to minus the log of the hydrogen ion concentration. All right, so 103.3 says find the pH. So if I'm looking for pH, I'm going to use this formula. Find the pH of a liquid if the H plus is 4.03 times 10 to the negative 6. All right, so put that in the calculator. I don't have the regular calculator, so I'll have to use this one. I'm going to put minus. I'll show you this in just a minute. Log of 4.03 with an exponent of, find it on here. This is a different calculator. I'm having a hard time finding where the exponent is. Oh, here it is, right in front of me. Okay. Okay, so this is what it looks like, and I'll just scroll over so you can see the rest. And then I'll hit enter. So the pH is 5.39. So pH equals 5.39. And if you guys remember, the pH of any liquid is always between 0 and 14, where neutral is 7. So if you get an answer that's not between 0 and 14, then you know you did it wrong. Okay, the last one says find the concentration of hydrogen ions. So we're looking for concentration of hydrogen ions, so I'm going to use the other formula. If the pH of the liquid is 7.05, so 10 to the minus 7.05 And in the calculator, remember that's the inverse of log. So we'll put the 10 raised to the power. That's what your calculator should show you, inverse log. And then we'll put in the exponent, which is negative 7.05. Don't forget to put the negative. And so the concentration of hydrogen ions is 1, 2, 3, 4, 5, 6, 7, 8. Wait, how many zeros? 1, 2, 3, 4, 5, 6, 7 zeros, 8, 9. All right? We're going to write that in scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we have to move it over here. So that's moving it 8 places, so that'll be 8.9 times 10 to the negative 6 is the concentration of hydrogen ions. Oops, not 6. Why did I do that? How many places did we move it? 1, 2, 3, 4, 5, 6, 7, 8. 8 places we moved it. So 8.9 times 10 to the negative 8. All right, that's all for lesson 103. Thank you.